All righty, we're back. 8-4, special right triangles. So we have certain kinds of right triangles that, because of their measures, we can easily determine the lengths of sides without having to do any real calculation. So we know that the sum of all the angles of a triangle is 180. Let's say, for example, we have a triangle that has two 45-degree angles and a right triangle. In that case, we have an isosceles triangle because these two angles are congruent. That means A is congruent to A over here. And the other thing is that the hypotenuse is going to be square root 2 times the length of one of the legs. So I won't go into an example or won't really prove that out. We can prove it out pretty easily because we can say a squared plus a squared equals c squared. 2a squared equals c squared. C is the square root 2 times a. So that says the hypotenuse is square root 2 times a. So as long as we know if we know the length of one of the sides, we can find the hypotenuse just by multiplying by square root 2. So in problem A, we already know that one of the sides is 12. Multiply by square root 2, we get the hypotenuse. Pretty simple. Well, what if we already know the hypotenuse, but we don't know the leg? Well, then we'll end up having to divide because the hypotenuse is square root 2 times the leg. We would have to, if we knew the hypotenuse, let's say in this example it's 8, we'd have to divide by square root 2 to get the leg. So when we divide by square root 2, in radical form, that's just 8 over radical 2. We'll have to do the multiply top and bottom. We get 8 square root 2 over square root 4, which is 2, and then 8 divided by 2 is 4, so we end up with 4 square root 2. So that's the case with a 45, 45, 90 triangle. What if we have another special right triangle, which is a 30, 60, 90 triangle? In that case, the side lengths are not going to be the same for the legs, but they're still going to be related. If we take the shorter leg, the length of the shorter leg, and the shortest leg is going to be opposite the shortest angle. That's a 30-degree angle there for A. So the shortest leg will be BC. If we just call that X, then the hypotenuse is going to be twice as big as X. And then the adjacent side, or the third side, or the longer leg, will be square root 3 times the shorter leg. So as long as you know, if you know it's a 30, 60, 90, you just need to know one of the other side lengths to find the other two. So in this example 2a, we know the 30-degree angle is right here. So therefore the shortest side over here is 6. Over here is X. We know that that is 2 times the shortest side, and that's equal to 12 for the hypotenuse. If we want to find Y, which is the other leg, it's just going to be square root 3 times the shortest leg, 6 square root 3. Sometimes we don't know we don't know the length of the shortest side, so we have to kind of divide back to get that. So in this case, the side we know is across from the 60, and we know that that is square root 3 times the shortest side. So in order to get the shortest side, we have to then divide by square root 3. And then when we do the rationalization, we end up with 8 square root 3 over 3. So now once we have found the short side, then to get hypotenuse, we just take this, multiply by 2, and we get 16 square root 3 over 2. Okay, so we've got a few classroom exercises here with 45s. The top 3 are 45, 45, 90s, 4 through 6 are 30, 60, 90. And then 7, 8, and 9 are various types of triangles that you kind of have to know something about them to know what their angles are. For example, this is a square. So the diagonal is going to split this into two 45, 45s. If this is an equilateral triangle, which it is, 20 by 20 by 20, then each angle is 60. And so this line, this altitude, is going to split it into two 30s and 60 and 60 there. Okay, so those are the classroom. We have some written exercises, and then we'll be heading into the next section. Thank you for watching.